G'day, my name is Stephen Townsend, performance engineer turned site reliability engineer, commonly called SRE. And I've noticed in the last couple of years that their performance engineering and SRE are often lumped together, as if there is a natural progression from one to the other. Having gone through that transition myself recently, I thought I'd have a go today at answering the question, is SRE a good fit for performance engineers for the next step in their career? So yes, my name is Stephen Townsend. I work for IAG, which is an Australasian-based general insurance provider. I live and work in New Zealand, in Auckland. I was a performance engineer for 13 years, both working as a consultant and internally in organizations. And I love performance engineering. I think it's a field with endless depth and opportunity. However, performance engineering is pretty specialist, and it was limiting my ability to move into tech leadership roles in this part of the world. So I picked SRE to pick up those more generalist skills and experiences, which I hope will ultimately make me a more valuable contributor to a wider set of situations within technology. So in this session, 3 things. First of all, a quick intro to SRE for those that don't know much about it. Then, what's the difference between performance engineering and SRE? And if you are interested in SRE, we'll talk a little bit about the skills and experiences which will help you get into the field. Part 1. What is SRE? So before we go any further, let's go back to the beginning. SRE stands for Site Reliability Engineering, and it is a term and now a role in the industry which is rapidly gaining popularity. SRE was started by Google in 2004, and the motto was, "It's what you get when you treat operations as a software problem." In DevOps, we often talk about developers operating their own code in production. Within Google, there are still 2 distinct roles. There are SDEs, software delivery engineers, and SREs, site reliability engineers. But the 2 work together with an agreed set of commitments to each other, which is what makes all the difference. SRE is now being adopted by organizations all over the world. Every organization has their own slight variation on what SRE means and how they implement it, and it can mean different things to different people. Last year, I attended a conference, SRECon 21, which is a conference all about site reliability. And one of the speakers, Naran Desai, in his talk Beyond Goldilocks Reliability, which is very good, by the way, you should watch it, it's free on YouTube, defined reliability as 3 things. Availability. Is my service available to the customers who need it? Performance. How fast does it go? Do we have capacity to meet the customer demand? And correctness. Is my service functioning as intended? So that's what SRE is, but what do SREs actually do day to day? Of course, it somewhat depends on who you are and where you work and what your role is. But here are some common examples. Service level objectives, or SLOs, are a core principle of SRE. An SLO is a target that we set related to the customer experience on a service. SLOs make sure that whatever we do, there's an actual customer purpose behind it, and we can measure that. In my experience, many organizations capture a lot of technical metrics about their technology, but they struggle to answer simple questions about the customer, such as, what are the customers doing right now? How has that change that we made last night impacted the customers? SLAs are a lot like SLOs, except that they are a formal agreement between 2 parties on an agreed level of minimum service. The term SLA is misused constantly in the industry. SLIs, or service level indicators, are the metrics we use to track SLOs. Finding good indicators to accurately tell us whether we're meeting an objective isn't necessarily straightforward. SREs help to define and track SLOs and SLAs and SLIs in an organization. Most SREs also provide on-call production support. for one or more services some of the time. The key difference between a standard ops engineer and an SRE in this regard is that SRE should also have at least more than half of their time freed up to work on improvement work. Engineering solutions to make on-call support easier in the future, for example, or to make systems more reliable. Being on call lets SREs learn more about the systems they support and reveals common issues and patterns which can turn into opportunities for improvement. It keeps SREs grounded in reality and will always be part of the job. Now, I just mentioned improvement work. Developing tools and utilities and products is part of the way SREs can do that. Developing products gives an SRE teams the chance to innovate, to try new ideas, to express creativity at work. The products they build can make the lives of SREs easier and can provide developers and other stakeholders self-sufficiency and independence to do more for themselves. When incidents occur in production, SREs find themselves on the front line investigating and resolving them. They'll often work alongside engineers from all kinds of other areas around the organization, which makes communication an incredibly important skill here. SREs are often heavily involved in what happens after an incident is resolved, by learning from what went well or not through blameless postmortems, and making improvements to avoid that same situation happening again in the future. There are parts of our technology stacks which developers don't usually have the experience to build and maintain, such as bare metal or virtual infrastructure, container platforms, storage, and networking. SREs fill that gap and are often the ones in charge of building and managing those platforms. As we build software faster and faster, and the complexity of what we build keeps increasing, we are constantly looking for ways to simplify and improve operational work. The goal is to decouple the complexity and the scale of our systems from the number of people required to operate them. Automation is talked about a lot, but simplifying ways of working is just as, if not more valuable. Removing unnecessary activities, focusing on what matters. Part of this is also innovating and trying new ideas. Sometimes the payoff for investing in a new concept or a product can be enormous in the long run. The first step in improving reliability is to measure it both from a technology perspective, but also the customer behavior and experience. SREs build, maintain, and improve observability tooling and platforms. The scope of this is enormous, including monitoring, logging, tracing, how we alert or respond to events, how we visualize and find issues, and work through data. We talked about simplification and innovation already, but obviously process automation is another approach to reduce toil, and toil is repetitive manual tasks. SREs aim to automate as much as possible of their work and make sure that the automation they do build is robust and maintainable. In summary, SRE is about operating software and continuously working to make that a more effective activity, and always keeping the customer at the center of all decision making. I see site reliability engineering as a chance to do things differently. I'm personally not interested in tackling the same problems in the same way we always have. I want to be part of thinking outside the box, operating software more effectively, simpler, better, with a focus on customer. The SRE role I see advertised in the industry right now is often just a rebranded platform engineer or sysadmin role, which I think is a real lost opportunity. If I had to condense down what SRE is to a few words, I'd stick with Ben Trainor's original definition of SRE. SRE is what you get when you treat operations as a software problem staffed by software engineers. Hopefully at this point you have some sense of what SRE is all about, so let's move on. Performance engineering versus site reliability engineering. Performance engineers are actively involved in measuring, testing, and investigating as part of their day-to-day work. SREs may also need to take a step further and make changes to a system or service to improve it or resolve an issue. Generally speaking, not always, performance engineers don't go that far. They find and they diagnose, but they leave the implementation of fixes to dev and to ops. This is a pretty big step up in responsibility. When you are the one who needs to fix the issues you find, it adds an extra layer of accountability. Performance engineers also focus in depth on the performance of a system or a service. I always define performance as how fast it goes, how much capacity it has, and how stable it runs. SRE looks at reliability, which casts a wider net than just performance. So as I said earlier, reliability does include performance, but also availability. Is our service available to the customer? Correctness, is the service functioning as intended? As a consequence, SREs tend to need a more generalist area of expertise and be able to work with all aspects of reliability. On the flip side, performance engineers will tend to have a deeper understanding of how to measure and improve performance due to their specialization. From my own experience, performance engineers mostly work on the delivery side of the work, testing in pre-prod environments, working as part of projects and programs and initiatives. This isn't always the case, but some performance engineers do significant work in production, but not as a general rule. SREs, on the other hand, predominantly work on operations and in production. They will be involved in delivery and design decisions from time to time, but the primary focus of any SRE is what's happening in production in the real world. Performance engineers tend to do the work, or at least they lead teams of other people in the delivery of strategy and testing, monitoring, investigation. There can be an element of trying to embed performance engineering practices into delivery teams, which was actually the focus of my previous role. But for the most part, performance engineers deliver. SREs deliver a lot of hands-on work as well. They are engineers. But an integral part of SRE is also culture change. Blameless culture, including blameless postmortems, making the choosing and measurement of SLOs part of the definition of done, raising the priority of reliability and design and delivery decision making. SRE ways of working are a shock for most teams and organizations. So the success of an SRE practice rides on shifting that culture to enable it. There are some tools which both performance engineers and SREs both use, including monitoring tools, logging, tracing across many different layers. Process automation, CI/CD tools, pipelines, programming and scripting languages, and defect management. But there are also specific kinds of tools that are unique to each role. Performance engineers, for example, tend to use a lot of testing tools, especially load testing tools for simulating volumes of activity on a service. They also quite often use dedicated data analysis and visualization tools for deep diving into large volumes of data. SREs, on the other hand, tend to use a lot of incident management tools, which a performance engineer may not have done much with in the past. Paging and alerting tools, cloud infrastructure and management tools, infrastructure as code and general infrastructure management tools, container and virtualization platforms and the supporting tools around that. In closing, I don't think performance engineering and site reliability have that much in common. I don't see it as a natural progression at all, but that's not to say it can't be. I think the reason the two roles are lumped together is because they both involve observability. But that's about the sum of it. Most performance engineers predominantly spend their time running tests, reporting results, whereas most SREs are operating and running production systems. I mean, that's a gross generalization, but the jump from one to the other is no small feat. I think probably the best fit for SRE is either an experienced developer who likes to think about the bigger picture of their code and how it fits into the software ecosystem in the business, or an operations engineer who's comfortable writing code and interested in simplifying and improving their work. Part 3. Let's say you are interested in becoming an SRE. What skills and experiences are going to help you prepare? First of all, cloud platforms. It is inevitable you'll find yourself operating and improving software that resides in the public cloud. So get yourself some confidence in that space. and not just knowing how to monitor apps and infrastructure in the cloud, which is what most performance engineers would have done, but get confident in building and maintaining resources in the cloud for at least one major cloud platform like AWS or Google Cloud Platform or Azure. I'm not usually big on certifications, but there are plenty of certifications and training courses out there to get you started if you're into that sort of thing. It's worth taking some time to also think about cloud and the unique constraints and opportunities that provides in the SRE or operations space. For example, the reduced visibility that we have of infrastructure monitoring when the cloud provider handles all that for us. And what does that mean for us? I knew the theory of containers and had load tested and monitored a few containerized apps prior to becoming an SRE, but I'd never really got my hands dirty. So right now, Docker and Kubernetes are the most popular technology combination in the space in the industry, Docker being the container engine and Kubernetes for container orchestration. And I highly recommend installing them and running them locally. Make sure that you can construct your own container images from some source code, spin them up, know how to use Kubernetes to manage a cluster of containers from the command line. There are very good online training courses for container technologies. I've completed some myself on LinkedIn Learning and Pluralsight, and they were both excellent. To realize the potential of SRE, it's helpful to be able to automate the creation and maintenance of your infrastructure. Infrastructure as code, technologies are becoming pretty widespread. The ones I've come across recently are Terraform, which is technology agnostic and can be used to spin up infrastructure on-prem or in the cloud. AWS Cloud Formation for spinning up infrastructure in AWS. And also Serverless Stack we use to create the infrastructure for a Slack bot. Observability is the modern buzzword that combines monitoring, tracing, and logging, as well as real user monitoring, or RUM, also sometimes called browser monitoring, synthetic transactions, alerting from that data, and visualizing those events in that data. If you worked as a performance engineer, it's almost certain you've already had some exposure to some of these tools and techniques, but probably not with a focus at looking at real production systems on a regular basis. Learn what it takes to make good use of these tools. Monitoring and APM tools provide only a fraction of the value they advertise if you just install them and hope for the best. To get the most out of them, you really need to involve some culture change. For example, getting developers to be involved with annotating and instrumenting code as they go as part of the definition of done, so that we can track the reliability of a particular customer interaction. The tools I've been using most recently are New Relic, Splunk, and Prometheus and Grafana. Think about how you can deal with the fact that there will be different teams across your organization using different tools. How can you pull all that data together and get that single pane of glass view? SREs work to reduce repetitive manual tasks, also known as toil. A key way to achieve that is through automation, automating whenever possible. So being comfortable with tools, CI/CD tools like Jenkins and Bamboo is important, but knowing how to automate things using scripting languages such as Python or PowerShell is also extremely useful and often a good starting point. SREs are engineers, and a lot of the potential lies in being able to create products that makes the lives of other SREs or developers easier. Having general purpose programming languages at your disposal is invaluable, not only for creating products, but for building automation and the glue that holds things together. There are lots of suitable languages, take your pick. The few that I've worked on most recently are JavaScript with the Node.js engine and PowerShell. In the past, I've used Python and Perl. Find a language that suits you and your team's needs. At IAG, we've been actively trying to hire people into our SRE team. And surprisingly, in the interviews, a lot of the candidates who are applying for the SRE role have never heard of SRE concepts and never mention them in the interview. If you want to apply for an SRE role, know the basic approaches and theory of why SRE practices were developed in the first place. In particular, I'd recommend reading up on SLOs and SLIs, observability, and process automation. It's a pretty good starting point. Google provides full books on SRE for free online, so there's nothing stopping you going online and getting familiar with it. But more than just for the job interview, my feeling is in the industry right now is that many SRE roles are really platform engineering roles which have been rebranded. And I think that's a missed opportunity, and I encourage you to strive to bring to life the potential of SRE rather than just do what we've always done in the past. Picking up the theory and concepts is going to help you with that. And lastly, if you can find the opportunity, provide on-call support for a production system. As a performance engineer, this is something I'd never done before. But when you're on the front lines handling incidents and requests, you get to see firsthand where the pain points are and what opportunities there are for SRE to make a real difference. I know this is slightly tricky to do if you aren't already in an ops or a DevOps team, but if you offer yourselves up as a spare pair of hands, you might be surprised how many people grab on the chance to get your help. In closing, performance engineers and SREs are apples and oranges. They're very different. The similarities lie in the field of observability, and that performance is one of the aspects of reliability. But beyond that, the actual day-to-day work of each role isn't very similar at all. Like I said, it would probably be easier for developers or ops engineers who have an interest in thinking about the bigger picture. However, if you are a performance engineer like me who's interested in taking in the bigger picture, the customer, production, how we build and maintain software, then SRE could be a good job fit for you. My warning is, though, that if your job mostly involves building and running load tests, it's going to be a massive shock to your system. Secondly, I think SRE is exactly what we need in the industry right now. Complexity keeps increasing. The desired pace of delivery is also continually speeding up. Even if blanket SRE isn't adopted across an organization, the purpose and the concepts are sound. Let's understand the customer and the impact we have when we make a change. Let's reduce manual repetitive toil work as much as possible through automation and simplification. Let's build healthy relationships between delivery and operations. That all sounds pretty spot on to me. Thanks for your attention. I hope that you got something out of the session. If you'd like to connect with me, I'm available on LinkedIn and Twitter. I also have a podcast called Slight Reliability, formerly called Performance Time, which is available on all major podcasting platforms as well as on YouTube. Thank you very much.